Good afternoon.
Good afternoon.
Just a moment.
Okay, let's see here. Let's get this. I've had every about every technical issue today that I could even imagine having in one day. So I hope you guys have. How was the quizzes? Any problems there?
I couldn't complete any quizzes because I had some stuff to take care of at home because last hour was my 6th hour, which is my senior release, and so I couldn't take the quizzes. And could I take them after class today?
Well, if the proctor is going to be there, is Crystal going to be there to?
Yes.
Yes. Okay. All right. All right. Let me.
Also, I had a question about quiz 3.2.
Okay.
There was a question, and it.
Okay. Wait. Stop right there. Okay. So if we've got people that haven't finished the quiz, then I don't want to talk about specifics of it. So, if you want to shoot me an email or a screenshot or just tell me what the issue was. I don't, otherwise I'm not going to talk about specific questions over the broadcast.
Okay.
All right. Okay. All right, let's see. Okay. All right. So let's see. Everybody here? Who are we missing in Winslow? Is that Chloe gone?
Yeah, Chloe's gone.
Oh, that's right. I knew that. I knew she was going to be gone. And how about in Mogyan? Everybody there?
Yeah, everyone's here.
Okay. All right. Let's see. I've got. Okay. Let's see if that will work. My normal flash drive is not working. All right, so we're gonna talk about differentiation rules. We're talking about the product rule when we finished up last time. Okay. Oh, so all right, I think we were about here. Does that look right? Anyway, where I marked our spot on that flash drive, anyway, it's not working here today, so I don't have my little bookmarks. So so I think we're right about on the 3.3, and we're on the back side, and we're right above practice 5.5. So does that sound right to everyone? Okay. let me switch the camera and then let's get started here. Okay. All right, so it says using only numerical values, we can test our understanding of derivatives. Now,
Mr. Strong,
yes.
did we find out the answer to the 5.5 practice? Because I don't think we went over the answer.
Okay. You know what? So that's the one I had you write down, right? Because it wasn't on your sheet.
Yes.
Yeah, so that's yeah, that's different. So I that's one of the changes that I made to the DIL. So I actually don't have that problem on this saved version. Okay, so let's go through it. Okay, so this is practice 5.5. And what was the problem? Find dy dx.
Y equals, in parentheses, 1/2 plus 1 divided by x, and that's enclosed in one parentheses. And then it's times 1/3 minus 2x squared.
2x squared or 2 over x
2
squared?
divided by x squared.
Okay. All right, is that right?
Yes.
Okay. So, does anyone think they've got the answer? All right. So, Jordan, tell me what you think, and we'll work it out and see if you're right.
I got 1/6 minus 6 divided by x to the third plus 3x squared.
Like that?
3 divided by 3x squared.
3 divided by x squared?
Yes.
All right, now? Is that right? Okay, so if we go through it, so what I'm going to do is I'm going to pick, so this is u and this is v. All right? So then u prime, okay, so the derivative of 1/2 goes away. That's a constant. So this is x to the minus 1, so it's negative x to the minus 2. All right, and then this is v, so v prime, the derivative of 1/3 goes away, and this is negative 2x to the minus 2. So negative 2 times negative 2 is 4x to the minus 3. All right, so any questions so far?
I just know I didn't do this right, so my
Okay.
answer was wrong.
Oh, dang it. Okay, so then dy dx, or y prime, is u times v prime. So I'm going to just put the v prime in front because it's just one term. So 4x to the minus 3 times 1/2 plus, I'm going to just write this as x to the minus 1 for now, plus u prime times v. So again, I'm going to write negative x to the minus 1 minus 2 first, and then 1/3 minus 2x to the minus 2. All right, so everybody happy so far? All right, so now doing some algebra here. So 1/2 times 4 is 2, x to the minus 3, and then plus 4, and then we add the exponent, so negative 3 plus negative 1 is negative 4. Oops, I forgot the x. Okay, now we're distributing the negative x to the minus 2, so that would be negative 1/3 x to the minus 2, and then negative times a negative is positive 2x to the minus 4. All right, so yeah, this is not going to be the right answer here. Okay, so now we do have like terms here that will combine these. And that's it. So the highest exponent is minus 2, so let's write that term first. So negative 1/3. And then let's go ahead and put use the elevator rule and put the x squared in the bottom. And then the plus 2 over x to the third. And then now our like terms, 4 plus 2 is 6. And then we have x to the fourth in the denominator. So did anybody else get that? No? And see any, did I make a mistake somewhere? We all good with that? All right, so okay, so now here's the deal. So going on to kind of what I started with that this part here, we can test our understanding of derivatives using numerical values. Now this is a very common thing that you see on quizzes, tests, final exams, and so on. Because what the problem that I'm going to show you, test to see if you know the product rule without getting bogged down in all the algebra. Okay, so that's really what it's all about here. Okay. So let's say, if we have the u of 2 equals 3, u prime of 2 is negative 4, the v of 2 is 1, and v prime of 2 is 2. So all of these values are at 2, the different values. So if I want to find, so if y is equal to u times v, and I want to find the y prime of 2. So what this means is I want to find the derivative of u times v at 2. But instead of giving functions, I'm giving numerical values. And so it kind of tests to see if you understand that, okay, so y prime is the u of 2, u times v prime. So 3 times 2 plus u prime times v. So negative 4 times 1. And so you get 6 plus negative 4 is 2. And so it's a fairly simple computation, but if you don't know the product rule, you're going to get it wrong. Okay? So, like I said, this is very common. I mean, on a lot of tests. So let's go ahead and try practice 5.5. They're on your sheet. Okay. All right, so Skylar, let's have you tell me, what do you have for the answer here?
Negative 75.
Negative 75 is correct. Great job. Any questions on that? Okay.
Could we just go over that, please?
Sure. So again, applying the product rule. So V prime, so all of these values are given at 3. So Y prime, you use it says that Y is U times V. So to get the derivative, it's going to be the U of 3 times V prime of 3 plus the V of 3 times U prime of 3. So the U of 3 is 7 times V prime is 4 times V prime is negative 17. V is 7 and U prime is negative 1. So then you work those out and you get negative 68 minus 7. So negative 75 is the final answer. All right. Any questions on that? Okay, now this is where, let's see, who was it? Was it Nathan that brought this up? Or was it Aiden? About that you could maybe multiply first?
It was me, not Nathan.
Okay, all right, well, let's make sure you get credit for that then. Okay, so some products can be differentiated faster by foiling first. And so I was exactly hoping that someone would notice that. Okay, so in other words, like let's say that we have something like this, and to use the product rule like we've been doing. So first of all, you have to make sure that you understand that Y prime is not U prime times V prime. Okay, you can't do that. All right, but what you can do is you can use the product rule like we've been doing. Okay, so if we go through, and I'm just kind of jumping to the end here, okay? Or the second thing that you can do is actually take your original problem and FOIL it first. And then if you FOIL it first, then you don't have to use the product rule. You can just do it term by term. Take the derivative term by term. And then if you look, see, that's exactly what we got up here in red using the product rule. So you might say, well, wait a second. If that seems a lot easier than using the product rule, why didn't you just show us that? Okay. The answer is because there are a lot of problems where you cannot FOIL. But you need to know the product rule. So I'm trying to teach you the product rule on easier ones to do. Okay? And so then later we'll do ones where it's impossible to FOIL, but you still have to use the product rule. So like for example, if I had y equals x squared times cosine x, see that you can't FOIL x squared through cosine x, so you would have to use the product rule on that. Okay? But for this one where they're both polynomials, you can use the product rule or you can FOIL it out and take the derivative term by term. So on practice 5.75, where it says find the derivative 2 different ways, then I want you to do it with the product rule. And then I want you to do it FOIL and integrate term by term, see if you get the same answer. Okay? So, Ms. Townsend, I did get your email right before class, and so I'll set that up. Okay?
Was it? Thank you.
Sure.
One too. Wait, I sent you another one too.
Oh, did you? Okay.
Yeah, so don't forget the tip.
That one I haven't got yet, so.
I sent it while we were in here, so
Oh, okay.
thank you.
Sure. All right, so Denon, which method are you doing first?
The FOIL.
Okay. So when you've got, do you have the answer yet?
Yeah.
Okay, what did you get?
10x to the fourth, or to the fourth minus 12 to the third plus 16x minus 12.
Okay. So that's the FOIL. You get it that way. And then when you do the U and the V, and you use the product rule, you get the same answer. So again, you got to make sure that you understand the product rule on this type of problem because they're going to get harder. And you're not, and a lot of them you're not going to be able to foil. Okay. So, did anyone have any difficulty with either method, the foil or the product rule, that it would like me to go through?
Can you scroll up so I can see the FOIL
Sure.
method?
So you're just foiling it out and then take the derivative term by term. All right, so let me know when you're done with that.
Yeah.
We're done. Thank you.
Okay. Okay, so just as the derivative of the product of two differentiable functions is not the product of their derivatives, the derivative of a quotient is not the quotient of the derivatives. So in other words, if y equals f of x divided by g of x, then the derivative is not f prime of x over g prime of x. Okay, so like the product rule, we're going to need a quotient rule.
Could you scroll up a bit?
So what is the quotient rule? Well, so the quotient rule says that if y equals u divided by v, then y prime, the derivative is, you start with the denominator v times the derivative of u minus u times the derivative of v, all divided by v squared. So it's a little more complicated than the product rule. There's also a minus in there instead of a plus. So then the order matters. See, the product rule, we didn't really worry about, okay, which one do you write? And you take the u times v prime, or is it u prime times v, or is it v times u prime? It didn't matter really for the product rule. But with the quotient rule, because there's a minus in there, the order matters. So, and this is how the book writes it. This is how I write it. So you start with the denominator. So it's v u prime minus u v prime, all divided by v squared. So, do any of you happen to speak French? Any of you study French? Anyway, there's a kind of a cool way in French. If you, je veux means I saw. Je veux, UV, like UV radiation, like light, with my two eyes. V2. If you don't know French, that doesn't really help them. All right, so here's an example. So what we're going to do is take the derivative here. All right, so is y prime u prime divided by v prime? No, it is not. You have to use the quotient rule. So you're going to start with the denominator. So the denominator is x squared minus 1. So you start x squared plus 1. There's the numerator. The derivative of the numerator is 2x. So the denominator times the derivative of the numerator minus the numerator, x squared minus 1, times the derivative of the denominator, which is also 2x, all over the denominator squared. Now, once you apply the quotient rule, really your calculus is done. And really what's left now is the algebra. And so we're going to distribute the 2x. So 2x times x squared would be 2x cubed. 2x times 1 is 2x. And then we're going to distribute the 2x and the negative through here. and get negative 2x cubed, and then negative 2x times 1, so positive 2x. All over the denominator squared. Now, you don't ever square this out. Okay? You just write it squared. Just leave it. All right, then you look to see if there's like terms. Oh, it looks like my x cubes cancel. 2x plus 2x is 4x over the denominator squared. X squared plus 1 quantity squared. And that's your answer. So you apply the quotient rule and then use algebra to combine like terms, cancel, whatever. All right, so let's see if you can do practice 6. I'll leave this one up for a minute. All right, Hannah Z, when you've got it. All right, do you need some help?
No, I'm still going.
Fourth.
Okay. Keep going. Okay, sorry I had to step out there for a second. I found out one of my high schools tomorrow isn't going to have internet, so that always makes life eventful. So Hannah, did you?
Internet tomorrow.
Yeah, I have it now.
Okay, awesome. All right, tell me what you've got.
2x to the fourth minus 12x to the third plus 16x minus 12 over 4x to the fourth negative or minus 12x to the third plus 9x squared.
Okay, couple of things. The denominator, you never have to multiply out. Okay? Just leave it as whatever squared. Okay? So that would save you a little bit of work. The second thing is that I think I heard everything was right. And I mean, what you said wasn't wrong. I'm just saying normally we don't multiply it out. But I think you said had a negative 12 here at the end. And see, it's minus a negative 12, so that will become a positive 12. So when you're foiling this out, this right here out, you're going to get a negative 12. 4 times negative 3 is negative 12. So then when you minus all of that, it's going to become a positive 12 in your final answer. But I think everything else you had perfect. Okay. All right. So would anyone like me to go through it? Okay. All right. Well, great job, Hannah. The reason, by the way, that we don't multiply out the denominator is because sometimes if we get down here and maybe we could factor out a common factor that will cancel with something in the denominator. And if we've already multiplied it out, we won't see that. We won't see that it'll cancel. So normally just leave it like that so it's ready to cancel if necessary. Okay? All right. So let's see. All right. These are a couple of different things that I've seen as far as how to memorize the quotient rule. So they think the numerator is high and the denominator is low. And so it's low D high minus high D low over low low. So just remember that low is the denominator. So you got to always start with the denominator. Low D high minus high D low over low low. Now, the one that I actually used to memorize the quotient rule was similar to this, and it was high over ho. And it was ho D high minus high D ho over ho ho. So a little bit of more Christmassy, I guess. So it's just replacing low with ho. It's the same pattern here. Okay. So just something, and of course, the more you can memorize of that, the more it'll help you. Okay. All right. Now, this is like a trick here. Okay, it says the choice of which rule to use can make a difference on the difficulty. Okay. Whoops. So like in this problem right here, see, it would actually probably be quicker when instead of using the quotient rule and the product rule mixed together here. Watch what I do. These are a couple of really good tricks. So so this is how I would have to do it with the quotient rule, because inside the quotient rule, I would have to do the product rule. And that, I mean, sometimes you have to do that. But let me show you a couple of tricks that might help you. Okay? First of all, instead of doing the quotient rule and the product rule in this, if you do FOIL out the numerator, then and combine like terms, well, now you don't have to use the product rule when you're taking the derivative of the numerator. Okay? Also, when you have a fraction that's divided by a monomial, instead of using the quotient rule, what you can do is split the fraction. Have everything over x to the fourth, and then you simplify those, and now you don't have to use the product rule or the quotient rule to do that derivative. So you do a little algebraic manipulation first, and it helps you out a little bit. Okay? So see if you can do that for practice 7. So take that derivative, and you can use the quotient rule if you'd like, or try splitting the fraction and see if it's easier. All right, so Rhett, when you've got it.
Is it 2x plus 5 over 2x?
Well, it might be 2x plus plus a negative 5. Okay, so instead of using the quotient rule, I just split the fraction, made it x squared over x squared, which is 1, 5x over x squared, which is 5x to the minus 1, and then minus 1 over x squared, which is x to the minus 2. And so the derivative here is 0. The derivative here is negative 5x to the minus 2, or negative 5 over x squared. And the derivative here is positive 2x to the minus 3, or 2 over x to the third. So, but doing it with the quotient rule is fine too. But I think your 5 should be positive. All right. Well, the last blank here. So we can interpret the second derivative as the derivative of the derivative, or y double prime, or the rate of change of the slope, or the acceleration.